Hello, I'm back. So in this video, I'm going to talk about feasibility analysis. If we remember the steps, we first generate ideas and then we do the feasibility analysis, which is going to prove a business case. We're going to know if the idea can be implemented in the industry or not. And for that, we will need to do market analysis, in which we are going to decide the capacity, the product price, these kind of things. So we need to do an analysis of the present and the future situation. In the present, we can tell, for instance, situation on site company. We can check the literature for seeing what companies are producing the product we want to produce, or what companies want to produce that, as well as the capacity worldwide. And the future situation, this one is a little bit more complicated because you would need to kind of estimate the price of the product in the future, and there is a lot of uncertainty about that, especially in this globalized world. But okay, so something we need to do is the investment cost. Okay, so let's call this 1 because we said this is 0, the idea, and this is going to be 1. And 1.1, let's say, what is that? Yeah, so 1.2, sorry, 1.1 is going to be the market analysis. And for this one, we will need to work with some people that are experts doing this. So, for instance, in Colombia, we call them the industrial engineers. Okay, then we will need to do an investment cost estimation. And for this, we have two methods. The first one is the global method, which is very easy. It's going to be the new investment is going to be equal to the old investment times the new capacity new over old capacity, to an exponent. And this exponent, we call it the degradation factor. Okay, and if we for most of the processes is around 2/3. Okay, it depends on many things, but we can think of so for most of the processes we will need to pay attention to the capacity itself based on volume, right? So we would need to do volume, and we are going to use material to build that, right? To build the equipment. So that's why the 2 comes from the area and the 3 comes from the volume. But if you have, for instance, membrane processes, you're going to have that the capacity depends actually on the membrane area, so it's going to be 2/2. So for instance, membrane process is going to be around 0.9. Of course, it's not going to be 1 exactly, because you will use some pumps and some equipment that you will need to design based on the area, surface area. And then there is another method which I find more interesting. So first one is the global method. Second method is called the detailed method, which is not very detailed. But anyway, it's a little bit better. So the investment, so this one we do it for equipment, is going to be equal to the price of the equipment on board, okay, times a factor which we call F-lang factor. And this factor is going to be, it can be 3 things. So if you have solid processes, this factor is going to be equal to 3.1. If you have solid liquid processes, this factor is going to be 3.6, around 3.6. But if you have only liquid processes like distillation towers, this factor is going to be 4.74. And maybe you're wondering why. The thing is that the people who build solid processes, equipment for solid processes, this price is going to be much higher because they integrate the control inside of the equipment. But for these kind of processes, they don't, the price of the equipment itself is lower because they don't integrate the, for instance, the controller of all of these sensors that are needed. So if you are dealing with only liquid processes, it's going to be much worth for you and for your team to put this liquid equipment to work, because you will need to design the controllers and all of that. Yeah, and that would be all about the investment cost. But then we need to design or to calculate the production cost. To calculate or to estimate, it's maybe better, which has units of million of euros per year, or euros per year. And in this one we will have two elements: the operational expenses and the capital expenses. And in the operational expenses we have something like the raw material price, or the waste treatment, or the utilities, catalyst, the personnel, the marketing, the research and development, and this is done, this is given in euros per year as well. And the capex, this one is going to take into account the investment, the interest, because you will need to pay interest for the money that you take for building the plant, and some maintenance, let's say, okay, let me fix it if I can. Maintenance. Okay. So for this, we need to know that profit is given by the sales minus the cost. And for having an interesting case, interesting, let's say, process case, or interesting business case, you would need at least 10% of investment per year of investment. Remember that when you have the of a percentage of, you're going to multiply. But yeah, anyway, that's basic mathematics. And then for this capex, we are going to use something that it's called the capital charge factor. And this capital charge factor is going to include 10% profit, right? The 10% depreciation, 10% interest, and 3% maintenance. So basically, what's happening here? Why you have again here investment, and why you have here some depreciation? What is that? So you will need money to build your process. That's what you are calculating here in the investment cost. How much money you need in year 0 to build the process, and then when you start running the operation, how much money you would need back to recover that investment. That's what we have here in the depreciation and the interest, right? Because depreciation is nothing than how much money are you going to get for selling the product, but you're not going to pay taxes on this money, because the government is not going to allow you to simply say, okay, in year 0 I invested 10 million euros. But you need to say, okay, I invested 10 million euros, but every year the government is going to tell you, okay, every year we will assume that you invested 1 million euros, and that way you don't need to pay taxes on this on this money that you're getting. And yeah, for an interesting business case, is going to be the following. It's going to be sales minus OPEX minus capital charge factor times investment that needs to be greater than 0. Okay, so the OPEX is easy to calculate because the OPEX it's based on the energy and mass balance. The investment is going to be around plus minus 20% of the actual value. You can have this uncertainty, it's going to be fine. And the estimation of future market, yeah, there are some reasons probably to stop the project. Yeah, and that's all what you need to know about the feasibility analysis.